Most browsers started to support CSS Flexbox back in 2013 to 2014. Flexbox has done a fantastic job of being able to control layouts in a responsive manner. Do we even need CSS Grid? Now we know that CSS Flexbox and CSS Grid have got various things in common, so let's start by looking at some of those things. So we can make Flexbox and Grid display divisions that would normally be displayed one beneath the other because they're block elements on a single row. All we needed to do with Flexbox was to set the display property to flex. Similarly, with Grid, we need to set the display property to Grid, but we also need to do something else. So for this example, I'm just going to be setting Grid template columns. When we do that, Grid also displays the divisions on a single line. If we stretch the window, we can see them flexing. Every value entry for the Grid template columns attribute becomes a column in the grid. By using the value auto, it causes each column to expand to fill the available space. Another thing that both Flex and Grid can do equally well is to control which of the elements are allowed to expand. For example, with Flexbox, we just need to set flex grow to 0 for any elements that we don't want to grow. And for Grid, we just need to replace the auto value with a fixed value. Something else that works the same is that by setting the container item's display property to flex or grid, so the same as the container itself, then the text within the items can be centered in the same way. So that's 3 things that CSS Grid can do,
but which CSS Flexbox can already do, so what is the point?
The point is, CSS Grid can do lots of things that CSS Flexbox cannot do, so let's look at those next.
So we can make items wrap onto a new line with Flexbox, as you've seen before, and we can also make items wrap onto a new line with Grid. But here's where the similarities between the two methods of controlling layouts starts to diverge. So we can see that when an item wraps onto a new line with Flexbox, it fully expands and stretches to fill the full width of the container. When we do the same thing with Grid, it doesn't happen. In fact, something quite nice happens. It falls nicely in line with the first column. So even at this stage, there is a little trick we can do to make CSS Grid work just the same as CSS Flexbox when it comes to expanding the item across the full width of the container. So we need to comment this line, Grid template columns, and style this line with the Grid column attribute, which is shorthand for Grid column start and Grid column end, which we'll look at in more detail in a moment. The first value 1 is referring to the first column, and it causes the 4th division to start at column 1. The second value, span 3, causes the 4th division to span the full width of all 3 columns. So this is really where we start to move into new territory with CSS Grid. I'm going to show you the difference between autofill and autofit, but just before I do that, let's quickly play around with the Grid template rows and Grid template columns properties, just so we can see how they work. The FR unit stands for fraction, meaning some fraction of the available space, and works similar to how FlexGrow works when using Flexbox. Just like FlexGrow, you can set FR values of less than 1, which then causes the column or row to be less than 100% of the available space. So let's play around with the Grid template columns attribute and see what autofill does compared to autofit. Now when we've got it set to autofill, you'll see that it's not taking up the full width of the container. You'll also see that as I change the width of the window, there's a kind of pulsing that takes place. And you might wonder what that is. It's because CSS Grid allocates the space for the elements, even if the elements don't exist within the HTML. So CSS Grid is attempting to fill the width of the container with 150 pixel wide items, regardless of whether the items exist within the HTML structure. You can also click on the DevTools to check exactly when the pulsing is occurring. As you can see, when the width of each division exceeds 189 pixels, there becomes enough space to add in another division if the 4 divisions are reduced to their minimum width of 150 pixels. But there's no division available to fill the space. If we now add another division to the HTML, we can see that it perfectly fills the space. So now I want to show you Grid Auto Flow, Grid Column Start, Grid Column End, Grid Row Start and Grid Row End. We'll start with Grid Auto Flow. So the default value for grid auto flow is row. Notice that there are 3 values within grid template columns, and we've got 3 columns, but there are 5 values within grid template rows, but we've only got 3 rows. And just like before when we looked at autofill and autofit, the space is being allocated even though the divisions don't exist within the HTML. So we've basically got 2 extra rows, one 120 pixels, one set to auto, that exist within CSS Grid's brain, but there are no divisions to fill the spaces. But this is a great opportunity to see how Grid Autoflow can come into play. When set to its default value of row, we can see how the divisions flow along the rows, but then when we change it to column, the divisions flow in vertically. And then when we change it back to row, the whole grid flows horizontal again. So that's what Grid Autoflow does. Now we need to look at grid column start. So we'll see we've got the first division at position number 1. So if we change that to position number 2, you'll see that it's moved along, but we've got an allocated space that's not filled. Move it across to position 3, and we've got 2 allocated spaces. We can now add another division and place it either before or after the one that we're manipulating the start position of. So let's add another division before, and we'll see that it occupies the first allocated space. Let's now add another division, and we can see it occupies the second allocated space. Let's undo that, and now let's add them in after the one that we're manipulating. Now we can see that division A appears immediately after division 1, which pushes division 9 onto the 3rd column. And then when division B is added, it pushes division 9 onto the 5th row, which is set to auto. Let's undo that and now look at grid column end. When set to 3, you might expect it to span 3 columns, but it only spans 2 columns, and likewise when set to 4, it only spans 3 columns. When you consider that vertical dividing lines each belong to 2 columns, so the one to the left and the one to the right of it, then for division 1 to span the full width of the container, it follows that grid column start, which refers to an item's left side, needs to be set to 1, which is the first vertical line, and grid column end, which refers to an item's right side, needs to be set to 4, because there's always one more vertical line than there are columns. Let's now set grid row start to 3 for division 5. You can see that it's moved to the 3rd row, but also notice that it's at the start of the 3rd row, whereas it was in column 2. However, we can move it back to column 2 by setting its column start value to 2. Or we can set it to span 2 to make it span across 2 columns. We can also play around with row start and row end in the same manner. Now the final thing I want to show you is grid template areas. Now be warned, it is definitely a puzzle to wrap your head around. It's not easy, so let's have a look and see what's going on with this. The grid template areas attribute allows us to create an overall rectangular grid layout by organising the elements into rows and columns. In this example, the first row corresponds to division 1, the second row corresponds to division 2, the top half of division 3 and division A, and the third row corresponds to division B, the bottom half of division 3 and division C. We've got some more CSS code here, and 4 out of the 6 division elements have been given ID attributes. So how on earth does that grid pattern that you can see on screen now come from that coding logic? Let's have a look and see if we can work it out. The IDs assigned to the HTML divisions refer to these 4 lines of CSS code. Each grid area attribute then looks up its value within the grid template areas attribute and produces some grid area for that particular HTML division accordingly. Now the first row within grid template areas is easy. It's simply causing division 1 to span across all 3 columns because division 1 is stated 3 times in the first row. For the second row, this is division 2, this is the top half of division 3, and this is division A. Notice at this stage that the grid area attribute for division 5 is commented, and so division A effectively has no ID, but it still corresponds to the first div 5 as being the first available division. Likewise for the third row, division B is the next available division for div 4. This is the bottom half of division 3 because there's only one HTML division that has div 3 as an ID attribute, and so that single division expands to cover 2 rows. That leaves just one last grid position, which is therefore occupied by division C. Now if we uncomment this line of CSS code, sure enough division A now also expands to cover the 2 rows. but notice how division C now resides in a newly created fourth row. The overall grid is still rectangular though, it's just that these two positions each require an HTML division element to fill them, so let's create those.
Finally, we can replace this div 1 with a dot if we like, and then division B becomes the first available division for that position. Division C moves upwards into row 3, and divisions D and E move over to the left. If we now recomment grid area for division A then becomes available to occupy the div 1 position, in place of division B. Some more shuffling takes place, which now leaves us with 2 unoccupied grid positions, so let's fill those, and let's finish off with one final dot.